Okay, let's talk about the number on top of the x. Okay? In other words, let's talk about how is in number 8 y equals 2 over x different than in number 9 y equals 15 over x. Okay? Taylor?
How far is it, like, stretches?
Yeah, we didn't talk about that yesterday. I didn't do a very good job of that, but technically the parent function for all of these is 1 over x, right?
Right.
And so if you have 2 over x, you can think of that as being 2 times 1 over x. And the 2 gives you a stretch of 2, okay? Whereas if you have y equals 15 over x, you can think of it as 15 times 1 over x. So that would give you a stretch of 15. So the best way to address that when you're graphing these, if you want to know the real what's up, the real what's up.
The RNet. Domain.
Okay, so if you are doing number 8 that says y equals 2 over x, and you're graphing that, here's the cool way to make this happen. First, think of the asymptotes. What's the vertical asymptotes?
X.
0. So I'm going to put a dotted line at x equals 0, which is a struggle right from the bat because there's already a line there. So some of you just didn't draw anything. What is the horizontal asymptote?
0.
Also 0. No, you don't have to, but I'm just doing that as a teaching thing. How do I know? I know because I can think of this equation as really being 2 over x plus 0 plus 0.
So the 0.
Okay.
There's no plus or minus.
Right.
Okay.
So if there's nothing being added on the bottom, then that means the vertical asymptote is going to be 0. And if there's nothing being added onto the end, that means the horizontal asymptote is also 0. Okay?
What if it was a 1?
Yeah, the domain and range, we'll get to that in a second. What?
Vertical is under.
Yeah, vertical is under. Vertical.
Is that one the opposite?
And horizontal is on the outside.
What was the opposite one? The one by the X?
The 1 by the x is the opposite.
No, what?
We'll
I
mess.
I hate lines.
Okay, hold on though. That's not even what we're supposed to be talking about. Okay? Shh, shh, shh. So you know, because of where the asymptotes are, that the graph is going to look like this and like this, right? But some of you are bothered by that gross approximation and you want to know a little bit more detail. Well, the best way to come up with a little bit more detail is to take 2 over x and plug in a number for x. And what's the easiest number to plug in for x?
1.
1. So when x equals 1, what does y equal? 2. So that means I know that the point 1, 2 is on the graph. Okay? If I wanted to, then I could plug in x equals 2, which would make y equal 1. And so that's going to give me this point right there. So do you see then the nice curve that we're going to get out of that?
So that's what we're supposed to do.
Okay?
I didn't do that.
I wasn't really hung up on you guys doing that or not. I just wanted you to get the general shape of it. But then some of you wanted to be a little bit more, you know, your OCD sort of kicked in. And you're like, well, where do I
You just said
draw?
yesterday, just make it as close as you can to the line.
Right, okay, and I'm good with that, all right? Then you could go, hold on a second, then you could just say, okay, well, I know that this is going to be symmetric down here, so I also know that this point and this point are going to be on the graph, and so I can draw this branch by going like that, okay? So now let's take a look at how that's different when we graph the next one, which is 15 over.
How do you do the domain range one?
Oh yeah, how do you do the domain and range? Okay, what?
Yesterday you said that I just draw the asymptotes,
Uh-huh.
so I didn't draw the lines.
Oh, I thought you meant that if it's on the, if the asymptotes are on the x and y axis, that you don't have to draw the asymptotes.
No, I just.
You do have to draw the graph, that's what it's all about. It'll be easy for you to just go through it. Okay. Okay, so the domain is all of the x values that the function can have. Okay? So if I start all the way over here at negative infinity, am I good? Yeah, because this graph goes forever here to negative infinity. So I'm going to go from negative infinity until, where is there a break? At 0. Okay? And then it starts up again just on the other side of 0 and goes to infinity. So here's what I'm here to tell you. This number right here and this number right here are going to be the same.
Every time.
Okay, well, it's going to be opposite, I guess. If this was x plus 3, that would move it to the left 3, so it'd actually be negative 3. Okay?
So that's always going to opposite of whatever it is.
Yeah. What's the range?
It's the same thing.
The range is the same thing, because I start down here at negative infinity, and then there's a break at 0, and then I go from 0 to infinity again. And so guess what?
The other one is
This number right here and
that's
this
the same
number right
sign,
here
right?
are going to be the same. Katie?
Okay.
Okay.
Can you just explain to me about how it's the opposite number?
Yeah.
I got vertical.
Okay.
That is the horizontal.
Okay.
That's all.
Katie, he's just going to go with okay. You slept.
Yeah, but now I feel like I did my whole assignment.
You didn't. So let's take a look at number 9 and see how it changes
How does it infinity sound so good?
when it's
What's the range?
15 over x.
0 to negative.
No questions.
Oh.
Okay, y equals 15 over x. So same deal.
Oh, Rich.
0, 0.
Yeah. It's plus 0 and plus 0, right?
Yes.
So that means that my asymptotes are both going to be at 0. Okay? So it's the same, except what I wanted to talk to you guys about in the first place is that 15 changes things, and I want to know how. Okay? And so once again, I'm going to pick an x.
1.
Okay, 1. If x is 1, this time y is 15. Okay? And so that means that point is going to be way up here. So that's kind of hurtful. I don't want to do that. It's too far away. So pick it. Okay, 3 is a good one because 3 goes into 15 evenly. So if x is 3, y is 5. Okay? And can you see that since it's an inverse variation, the reciprocal is also true? These two numbers are always going to multiply together to be 15. So if x is 5, then y is 3. Okay? And so if I think about this compared to the other graph, yeah, it's been stretched out. Okay? That 15 there stretches the graph. So it took what was down here and pulls it farther away from the x and the y axis. And then the same thing is going to be true in the third quadrant. -5 and -3 will be on the graph, and -3 and -5 will be on the graph. So it's going to look like
we
that.
don't have to do that, right?
Nope, you don't have to do that.
But you want us to know how to do it.
No, I didn't even care. But like people kept asking about the number on top, the number on top, the number on
Well,
top.
it's kind of
So
complicated. Like
answer
why?
it. Yes.
So, say it's like 7 on top. I know 1 goes into it, but don't you need 4?
Yeah, so you'd really, I would go 1, 7, and then I would go 7, 1.
Oh,
You could just,
you got you, Katie.
I did get you, and I'm going to get you on, I'm going to get you, no, I'm going to get you on that.
But it's right
I'm going to get you on that.
paper.
Yes.
So asymptotes, like, I can just show you. It's on my desk.
All right, so as Taylor pointed out, for the first 5, domain and range are all the same. Yeah, all that's changing is the number that's on the top, although 10 and 11, there's a negative on there, so it flips, but other than that, it's the same. So what's the one we did from the next group?
18 to 28.
What?
18 to 28.
18 through 28. I didn't make you do all of them, did I?
Yeah.
Nice. All right, 18.
That's why we don't know how to do it.
Now things have changed just a little bit. It's still 1 over x. So the vertical asymptote, because think of this as being x plus 0, the vertical asymptote is still at x equals 0. Okay? But now the minus 3 is going to take and shift the whole graph down 3. So the horizontal asymptote will be at y equals -3. Okay?
Okay.
So once again, if you want to be fancy, pick a number for x, plug it in, find a point, and that'll tell you how far away the graph should be from the asymptotes. I don't really care. Okay?
No, the
Here.
part where you guys want to know why.
And here, okay, are the asymptotes.
Is it?
Now we need to figure out the domain and the range because that's changed a little bit.
Domain is at 0.
Okay, the domain is going to be,
Negative 0.
the domain is going to be, yeah, we're looking at the x's. So you go -infinity to 0. And you go 0 to infinity. So that didn't change because this asymptote didn't change. The range, however,
It's gonna be different.
is -infinity to
-3.
-3, and then -3 to infinity. Okay?
Is there a special way to get?
Okay, it's I have a question. Is there?
I'm looking at
What's your
it.
question,
Paper,
Taylor?
I was drawing 8. What?
I said, what's your question, Taylor?
We basically are all. Never mind.
Pay attention. Now you can tell stories about spring break.
Wait.
Ah.
Whoa!
He was talking about his
Jeez.
metabolism.
He was what?
Talking about his metabolism.
Yeah, that's not paying attention. Is it?
So would 19 be the same as
Trying to keep the
18?
star picture eligible,
Yes.
and it's a lot of work.
Wait, so is 19 the
You
same
should
as
get
18?
some of your dad's coaching salary
Yes.
for doing the extra work to maybe
Besides,
pass
if you
them
want
on.
to be an overachiever, and
Just pay like $10.
I'll take 5.
Oh, this is true.
You got 2 kids in college, I'll increase.
Actually, you got one high school.
Yeah, but
But she's basically
she's basically. It's not.
She's gonna move it up.
We're already paying money to the college, even though she's not there yet.
Whoa.
You have to pay, I don't know, she had to pay her commitment fee.
Down
How is
payment.
it? How much is that?
It's $300.
That's
That's nothing compared to
That's a
Yeah, what it's gotta be
to
to like a university.
We got it.
Still gonna be.
No problem.
Makes a lot of
You're gonna see me next year wearing the same outfit every day.
We can't afford to buy our clothes.
You take out the
Mackenzie
Parents
was
take out
not.
loans for
Whoa,
college
that
for
was
their
weird.
children, or is that not possible?
What video?
The history video?
Oh, that's 0.
okay.
Okay, just show me how to do this one. So I
Yep.
did it right, and then I need to finish the rest.
Okay, so 20. Hey, no.
The range is
20. Now we've got a number under the fraction and we got a number at the end of the fraction, so both our asymptotes are going to be different. So 1 over x minus 2, Katie will tell you that since it's negative underneath, the vertical asymptote shifts the opposite direction.
So it's
So instead of being at -2, our vertical asymptote is at +2. And then the +5, just like before, moves the entire graph up 5. So that's where my asymptotes are. If you want to be cool, then you'll pick a number and plug it in, and that'll tell you where your graph is going to be. The easiest number that I can think of that will work is 3, because 3 minus 2 is 1. 1 divided by 1 is 1, and 1 plus 5 is 6. So that means the point 36 is going to be on the graph, and so that means that graph is pretty close to the, right? What did you say?
Graph is pretty close to you know, right?
6,
But it's below the thing.
1, is that what you said?
3.
What did you say, 6, 3?
Thumb?
Not when you have this -2 plus 5 stuff in there. That totally screws it up. So So this graph is going to look like this. And then that point would also be right there.
Domain and range.
It's going to look like that. So domain is easy. It's from negative infinity to 2. And from 2 to infinity. And the range is from
Negative infinity.
negative infinity to 5. And 5 to infinity.
Okay.
Yeah.
Yeah, it was about.
Just
Right.
right, negative infinity.
Yeah, that's the answer to why that doesn't work.
Thank God I